Hi guys, this video is on AP Calculus AB and BC 2024 FRQ3. So that's the same FRQ which came in both the exams. So it's on differential equations, slope fields and all. So let's get started. The depth of seawater at a location can be modeled by the function h that satisfies the differential equation, where h is measured in feet and t is measured in hours after noon. It is known that h of 0 is 4. Okay, excellent. Now, a portion of the slope field for the differential equation is provided. Sketch the solution curve y is equal to h3 through the point 0,4. Pretty straightforward, right? All you have to do is trace the slope field. So it looks like that it is going like this. It's going straight, and that's where it started to take a turn. So it takes a turn here, and then it started going down, and down. So this is how I think the slope field trajectory is looking like. All right, let's move ahead. This one says that between 0 to 5 it can be shown that h is greater than 1. Okay, h of t is greater than 1. Find the values of t for which between 0 and 5 for 0 to 5 at which the h has a critical point, and determine whether the critical point corresponds to a relative minima, maxima or neither, and justify your answer. So we very well know that the critical point is defined when dh over dt, or the derivative of that function, is either 0 or undefined. What is dh over dt? Fortunately, that's already given to us in the question. That's 1/2 h minus 1 cos of t over 2. And don't you think it can never be undefined? Because I mean, had there was something in the denominator, I would have said that, okay, set the denominator to 0, or had this was tan or something, it would have been undefined. But we know that h minus 1 can never be undefined. Cos of t over 2 can never be undefined, because cos is always between -1 to 1. So I'm just gonna resort to 0 here. So since the product of two things result in a 0, it means that either the first thing is 0 or the second thing is 0 as per the 0 product property. Okay, but don't you think I can safely reject that h is equal to 1? Because they have already said that h is always greater than 1. So h equal to 1 is not possible, and that's the reason why they gave this information. So the other information, or the other equation which I have, is cos of t over 2 is equal to 0. And cos is 0, I think, in two quadrants. Cos is 0 in the unit circle. Cos is 0 at two angles, right? Either the angle is pi over 2, or the angle is 3 pi over 2. And obviously I'm going to add a 2 and pi to both of these so that I get the general solution. So let's take this one by one. First, let's multiply both sides with 2. So that's going to look like pi plus 4 and pi. And this is going to look like 3 pi plus 4 and pi. This is no calc, by the way. And we have to make sure that the time is between 0 and 5. Let's start by plugging in n as 0. So if we plug in n as 0, we are going to get the first time as pi, which is 3.14, which is obviously between 0 and 5. But here I'm gonna get 3 pi, which is not allowed, right? Because 3 pi is like 9 point something, which is greater than 5, so that is not allowed. So if 3 pi is not allowed, how can the other n be allowed, at least for the solution? Because obviously it's going to be even more than 3 pi. In fact, negative values are also not allowed, because the moment I will put n as -1, 3 pi minus 4 pi is negative pi, which is not something which I need, because the time is always positive. So the other value of n can be 1 here, but that is also not allowed, because that's going to give me 5 pi, which is obviously 15 point something. So no, that is not allowed. So the only value, or only critical point which I have, is t equal to pi. Now let's find out whether this pi has a local max, local min, or neither. So I'm going to use a first derivative test. And for this first derivative test, I'm going to make a number line, I'm going to indicate a pi here. I'm going to indicate the terminal points as well, which are 0 and 5. And I'm going to put a number less than 5 and the number greater than 5 in the derivative equation, which is this one. I'm just looking for a sign change here. So less than pi, let's put pi over 2. And I don't really have to worry about this expression because h is always greater than 1, like we said earlier. So this is always positive. So what about cos of, if we put t as pi over 2, this will become cos of pi over 4, and cos of pi over 4 is positive number, so I will put positive. And if I put greater than pi, maybe 3 pi over 2, 3 pi over 2 is 3 pi over 2, which is less than 5. So if we put 3 pi over 2, this will become cos of 3 pi over 4, which is a negative number. So clearly, since the first derivative is changing from positive to negative, this is a local or relative maxima. Relative maxima over here. Do they need anything else? To my critical point. Okay, they don't need the, sometimes they ask that what is the relative maximum value. So I was just reading whether they need that. I don't see it anywhere, so I don't think so they need it. So that's it. This is the answer for this one. Moving ahead, they want us to use the separation of variables and find a particular solution of this thing. So that's easy. All we need to do is separate the variables. So dh over dt is going to be 1/2 of h minus 1 times cos of t over 2. I'm going to rearrange this a little bit. So I think I'm gonna club the family of h together and club the family of t together. How am I going to do that? So I think I'm going to multiply 2 both the sides. I'm going to divide h minus 1 both the sides. Then I'm going to multiply dt both the sides, and cos just remain as it is. And then I'm going to integrate. So I mean, obviously I can put the integral sign here, but okay, fine, just to avoid confusion I'll put it here. And the next step, I'll just take 2 outside the integral because it's a constant multiplied. It's nothing to do with it. So this is dh over h minus 1. This is cos of t over 2 dt. What is the integration of 1 over h minus 1, guys? I think it's ln of absolute value of h minus 1. Integration of cos is sine, but be careful here. This is t over 2. This is not t. So there's a shortcut which says that if, as per the property, if the integration of cos is sine, then if there's a coefficient of coefficient in the with the t, then you just divide by that coefficient. So I'm going to divide by 1 over 2, plus obviously we have a constant of integral over here. All right, excellent. So what next? I'm gonna say, by the way, h is greater than 1, right? It was given earlier. So I think I can just safely remove this absolute value because greater than 1 minus 1 is always positive. So absolute value has no job here. So it's 2 ln h minus 1. H minus 1 is equal to 2 times sine of t over 2. This 2 came, by the way, from the KCF, keep change flip. And now I'm going to use the initial condition that h of 0 is 4, which means that when t is 0, h is 4. So this gives us 2 ln 4 minus 1 is equal to 2 sine 0, 0 over 2, 0 plus c. So 2 ln 3 sine 0 is 0 plus c. So I got the constant as 2 ln 3, which I'm going to sub in over here. This is going to look like 2 ln h minus 1 is equal to 2 sine t over 2 plus 2 ln 3. Although we have solved this, but they are not really a big fan of this form because they want y to be isolated. So if any one of you has left the answer here, don't worry, you will still get, I think they will take off 2 points from it if you have left it here. 2 or 1, I think, because this, I think this question is of 5 points. So if it's of 5, then you will lose 2 points if you have left here. But yes, of course, we'll just continue and isolate h from here. Okay, so I'm gonna subtract 2 ln 3 both the sides, so that all the, clubbing the lns basically. So negative 2 ln 3 is equal to 2 sine t over 2. Taking 2 as a common factor, I'm left with ln a minus ln b. Why am I saying ln a minus ln b? Is because immediately in the next step I'm going to apply ln a minus ln b is ln a over b. So ln of a over b is equal to 2 sine t over 2. If my work is correct, 2 and 2 is gone. So I'm left with ln h minus 1 over 3 is equal to sine of t over 2. So I'm going to say that h minus 1 over 3 is equal to e raised to sine of t over 2 by taking anti-log both the sides. And finally, it's going to make some space here. So finally, the answer looks like multiplying 3 both the sides. So h minus 1 is equal to 3 times e raised to sine of t over 2. Finally, adding 1 both the sides, we have h is equal to 3 e raised to sine of t over 2 plus 1. So this is h isolated here as a function of time, and this should be our final answer. Hope this makes sense. Any confusion, please post it down in the comment section, and I'll be happy to help you there. See you soon in the next video. Bye bye.